Hello viewers, in today's class we are going to discuss these three very important and well-known integrals, right? And here we are not going to solve these three integrals with the usual method, right? So we have already solved these type of integrals in a detailed manner in our earlier videos, right? So here I will use the direct method or the direct formula how to get the values of these integrals instantly, right? So let us start. Now see, sometimes we come across with some important and well-known integrals, right? And in such cases, if we directly know the formula or the direct result, then it is very convenient to get the answer of these type of integrals, right? So here in the first case we have this integral that is 0 to 1 x minus 1 divided by log x. In the second one we have 0 to 1 x cube minus 1 and log x, and in the third integral we have 0 to 1 and square root of x minus 1 divided by log x, right? So if we rewrite these three integrals like this, that is 0 to 1, and x minus 1 can be written as x raised to 1 minus 1 divided by log x, right? Now the second integral is simply, we can again rewrite it as such. So we have x cube minus 1 over log x dx, right? And the third integral is from 0 to 1, and here square root of x can be taken as x raised to half minus 1 divided by log x dx, right? So we see that these three types, or these three integrals, are of this type, that is 0 to 1, the lower limit is 0, the upper limit is 1, and we have x raised to n minus 1 divided by log of x dx, right? So these three integrals are similar to this one. See, here we have x raised to n minus 1 over log x. So here we have x raised to 1 minus 1 divided by log x. So we have n is equal to 1, right? And in the second integral, we have x cube minus 1. So here we have n is equal to 3, right? And here we have x raised to half minus 1. So here n is half, right? So now whenever we come across with this type of integral, then the direct value of this integral is simply a log of n plus 1, right? So the value of this integral, that is 0 to 1 x raised to n minus 1 divided by log x dx, is the log of n plus 1, provided that n is greater than minus 1, right? So this is the condition for the validity of this integral, right? So with the help of this integral, we can now write the direct values of these three integrals. So now in the first case, see, we have n is equal to 1, right? And we can now write log of n plus 1. So n is 1, so we have 1 plus 1. So that is the log of 2. So the value of this integral is simply log of 2. Now in the second integral, we have n is equal to 3. So now we can write log of 3 plus 1. So this is the log of 4, and this can be written as 2 log 2, right? And in the third integral, we have n is half. So we can now write log of half plus 1, right? So here n is half. So we have log of 3 over 2. So the value of this integral is the logarithm of 3 over 2. So this is how we can solve these type of integrals with the help of this result.